Hey, Math Amigos. Mr. Mac is back with Chapter 7, Equivalent Ratios. I'm going to tell you right now, if you know anything about equivalent fractions, you're going to be good to go today. All right? You should already know the terms simplest form, greatest common factor, and you know what? We even touched upon equivalent ratios yesterday, so you should be able to see where this is going. Some of you should be like raising your hand and offering to teach the lesson right now. All right. Equivalent ratios will show the same comparison of numbers. Okay. Jack's got 4 red apples and 8 green ones. The ratio of red to green is 4 to 8. Now Jack's going to divide them up onto trays. He's got 2 trays of red and 4 trays of green, with a pair of apples in a tray being 1 unit. He's got the number of reds to green is now 2 to 4. It was 4 to 8. Now it's 2 to 4. Those are equivalent ratios. Okay. This equals this. This equals that. You getting the idea? That's why he's making that face. Pretty tricky. Now the ratio is 1 to 2. Oh my goodness, that, and that are all samesies. All right, are we done? Or would you like me to continue? I'll continue. So those are all the same ratios. Naturally, the one with the smallest number is written in simplest form. If I can get my giant head out of the way. Nope, come on. Going into panic mode. Okay, let's clear the screen, let's continue. Okay, the ratio of the number of pencils to the number of push pins. When they say they're giving you this bit about the number, they're saying count it out. Okay, so 6 to 12, 6 to 12. Now there are how many groups of pencils? I just heard you all scream it, yay. And how many groups of push pins? Excellent. So the ratio now is 3 to 6. Do you think they might regroup them again? I bet they do. I bet they do. I'm a genius. 1 group to 2 groups. So the equivalent ratio, so the ratio of the number of pencils to number of push pins is 1 to 2. The equivalent ratios we started out as 3 to 6, and what's the last one? 2 to 4? 2 to 4, and 1 to 2. And these equivalent ratios in the simplest form, it's 1 to 2. The ratio that shows the actual numbers of pencils and push pins is what? It's 6 to 12. Alrighty? Oh, words. Talks about using the greatest common factor to write ratios in simplest form. That means find the largest number you could divide both terms by. Okay, so when we did that last one, we had 6 and 12. They initially divided each one by 2 and brought it down to 4 and 8. But instead of 2, you could also divide by 3. 6 divided by 3 is 2. Oh, and 12 divided by 3 is 4. Or you could divide each one by 6, and that's how you get the 1/2. Okay? In this case, they're doing 4 to 6. Divide each one by 2, and you get 2/3. Okay, if you can't get any smaller numbers, then you're done simplifying. A little bit like fractions? Of course it is. Oh, wow, this looks very familiar. Okay. In this case, the greatest common factor, the largest number 12 and 4 both divide by is 4. So divide 12 and 4 by 4. Divide 12 by 4, 4 by 4, and you get 3 and 1. Okay. Next, find the greatest common factor of 9 and 15. What's the largest number that goes into 9 and 15? Oh, yes, it's 3. Excellent work. And your final ratio is 3 to 5. Well done. You can, oh, this is fun. You can find missing ratios. or missing terms. Okay, this is like a incomplete equivalent fraction problem. So if you have 2 to 5 equals 6 to what? You want to see how you get from the first term to the first term, and that'll tell you how to get from the second to the second. Okay, so I know to get from 2 to 6, it's times 3. So then my 5 is also going to be times 3, giving me the missing 15. Okay? To figure out what you're going to do, you're going to divide 6 by 2. And you get 3. And then 3 tells me that I'm going to multiply that by 5. Okay. Is this the same set of problems? It's different thoughtful people. All right. What's a number that goes into 15? Oh, wait. How do you get from 12 to 4? We're simplifying ratios. How do you get from 12 to 4? Divided by 3. What do you do with your 15? Divided by 3. Oh, she's so smart. If you're not sure what you're dividing by, you can do 12 divided by 4. And that gives you the 3 that you're going to use there. All right. You guys didn't even have to work for just a while. Oh, ha, ha, ha. Fill this out. I'll do the same in about 5 seconds. So pause me until you're done. All right, this one here, I'm getting from 4 to 20 somehow, times 5. So 3 times 5 is 15. 20 to 15. 20 divided by 4 is 5. 3 times 5 is 15. Oh, it has me do it both ways. Excellent. How do I get from 7 to 21? Times 3. 12 times 3 is 36. Oh, I had a brain toot there. Okay. 21 divided by 7 is... Oh, did you guys stop me there? Ooh, Mr. McCarthy. What times 3 is 12? Oh, Mr. M. 21 divided by 7 is 3. That's why you slow down and check your work. 12 divided by 3 equals 4. Okay? Trying to find the missing term in your ratio. So this is what we're looking for right here. 16 divided by 8 is 2. Something divided by 8 is 3. 16 divided by 2 is 8. Or 3 times 8 is 24. Hip hip hooray. I said hip hip hooray. Oh, wait. I didn't quite finish. 3 times 8 equals 24. Alrighty. Muy bien. Hey, if you got cubes, good for you. Rock the house. If you don't, because you're either doing virtual learning, you're home not feeling good, we'll just have to skip this part. All right, practice. Mr. Jefferson's got a lot of work for you to do. Pause me, and then in 5 seconds, I'll start blasting through this. All right, 3 boxes with 5 each is 15. 8 boxes with 5 each for white is 40. The ratio of the number of yellow to white is 15 to 40. The ratio of the number of boxes of yellow to white is 3 to 8. What can you say about these two ratios? They are equivalent. Good. Let's carry on. Oh, and I'm even in the way. Watch out, you handsome devil. All right. I'm going to give you a head start. If you need more time, pause me. Otherwise, I'm starting in about 5 seconds and treating it like a race. I'm like totally serious. Now it's down to 4 seconds. If you want to stand a chance, you might want to pause me right now. Otherwise, if you think you got your you're starting already? You're starting already? It's on. Wait, what? I wasn't ready for that one. So not fair. 2, 2, 4. Come on. 2. Okay, got it. I think all of those are right. Kind of fun when we race, isn't it? All right, let's practice some more. If I got anything wrong, tell your teacher. Have a good laugh. Oh, we did it in just over 10 minutes. 2 pages. Y'all can do this. There's probably going to be a problem with the lesson. You can handle this. It's just filling in the missing terms and equivalent ratios. Get your workbook pages done, your IXL, and all of that, and we will be seeing you tomorrow. I'll do one more day in the orange shirt, and then I'll do a switcheroony. All right? Bye.